Alrighty, so at this point you should have lines 1 through 16 of your tree already put into Desmos, already figured out as far as their equations are concerned. You've got most of your tree done. It's just missing some lower branches. Because I told you to hold off on 8, 9, 10, and 11. I think this is how I had them labeled. What we're going to learn today is how to come up with an equation of a line where you do not know the y-intercept. So this column of our paper was the given column, right? And before we had M and B all over, right? But for these lines, we don't have B. However, I do want to point out, we do know what M is, right? For each one of these, we can find the slope. For example, line 8 here, our slope is 1/2, our slope is 1/2, right? Line 9, our slope is -1/2. We can do this for each one of them. Line 10 is 1/3, line 11 is -2/3. So what we are missing though is that B component, right? So we'll come back to this Christmas tree in a second. What the sub has hopefully passed out already are the notes for point slope form. So if you read this box, it says we use the point slope formula when we are given a point and the y-intercept of a line. Okay, then in parentheses it says when we are not given the y-intercept. So when I say a point, I don't mean the y-intercept. I mean like a random point that technically doesn't have any meaning. Okay, what point slope form actually is y minus y1 equals m times x minus x1 all in parentheses. It looks really complicated, but it's really not. So go ahead and have that jotted down. Just like we've seen previously, that y1 and x1 doesn't mean anything fancy. It just means the first y from a coordinate and the first x, which really only going to have one coordinate, so they're not even that necessary. But the y and the x here, this y and this x, those are going to stay as a y and an x. You're not going to actually have a number plugged into them. So let's just try an example. I think it's easiest to learn this just by jumping in. Number 1 says write an equation that represents a line having a slope of 2 that passes through the point 7, -2. Write your equation in slope-intercept form. Well, again, just to kind of establish our goal, slope-intercept form we know is y equals mx plus b. Okay, well, do I have my slope? Yes, it's 2, so I've got y equals 2x plus. Do I have the b? Do I have the y-intercept? Well, no. Y-intercepts say 0 something, right? 7, -2 is a point somewhere else in our coordinate plane, so we can't finish this equation yet. However, with point slope form, we can. So I'm going to go ahead and write point slope down again. It's kind of like starting with your formula when you're doing a geometry problem. And I'm going to start plugging in my pieces. Y is going to stay a y, okay? Minus y1. That's the first y from our point. So here's y right here. So we've got -2. That makes this a plus 2. Okay? Equals m is our slope. They gave us that as well right here. So 2. Then I keep going, parentheses, and this is going to stay in x minus my first x. That's this one right here, 7. Now it's just a matter of simplifying this equation and working it out, okay? But where we have stopped right here, this point in our work, this is the point slope form, okay? So I'm going to go ahead and simplify this by distributing the 2. So I've got 2x minus 14. Then I'm going to subtract 2 from both sides because I'm trying to get slope-intercept, sorry. Coming over here, so y equals 2x minus 16. Voila, I have slope-intercept form. So looking back at what my goal was over here, I already had the 2x part. What this ended up being was a 16. And I want to point out, was the 16 given to us anywhere in the problem? No, right? That was nowhere to be seen. But when we did the math with point slope formula, it eventually came out. Oh, I wrote plus. It should be minus. Sorry. Minus 16. Okay? So let's do another problem. Just keep practicing. Write an equation in slope-intercept form. So again, our goal here is y equals mx plus b, with a line having a slope of 3/2. Okay, that's good. I got part of it. That passes through the point -4, 1. Well, that is not a y-intercept. That is a point. So I have to use point slope form. So I'm going to start by writing it out. You don't have to do this every time, but it's a good thing to do at the beginning when you're first learning. And I'm going to start plugging in the pieces that I have. I know that these things are always going to be there. The holes that I left are what I plug in for. So y1, that is the y from my point. So in this case, it is the 1 equals m. Well, that's my slope. That's right here. So 3/2 x minus x1, that's the x from my point, negative 4. Since it's minus, it's plus 4. So now I just have to work it out. I'm going to leave that minus 1 alone for now. I'm going to distribute first. So y minus 1 equals 3 halves x plus 6. 3 times 4 is 12, divided by 2 is 6. Then I'm going to add 1 to both sides. So y equals 3 halves x plus 7. There is my slope-intercept form. Now I can see my slope is 3 halves and my y-intercept is 7. All right, let's keep going. Number 3, write an equation in slope-intercept form of a line having a slope of negative 4 that passes through the point negative 1, 5. Okay, this would be a good time for maybe you to pause the video and try this on your own. This is not a weird problem. This is no different from the couple we just did. So start with point slope form that we just learned. Plug these pieces in, work it out, simplify, see if you get the answer I'm about to show you. So go ahead and pause now and try this one on your own. Okay, go ahead and work it out. Hopefully you've already paused. Oops, that's a minus sign. So I've got y minus 5. Make sure you distribute the negative. If you mess up, that could be where it is. Distribute your negative. 5. So we'll go over here. Y equals negative 4x plus 1. Alrighty, hopefully you did okay. It's really, again, it doesn't get any harder than that. I'm not going to throw anything weird at you. You're just making sure you're plugging in the right things. So number 4, write an equation in slope-intercept form of a line having an undefined slope, that's interesting, that passes through the point 5, negative 3. When I hear undefined, I should automatically think Vux. Undefined as a U, Vux, right? So I know this is a vertical line. I know the equation would be x equals something, and I know obviously it's undefined slope. As soon as I think of Vux and it's saying to write an equation, well, whether it's slope-intercept formed or not, the only equations I have for Vux problems are x equals a number, right? That's the equation for every single vertical line. We don't really have slope-intercept form. We don't really have point-slope form. We just have x equals a number. That's all it is. The quick and easy way to do this problem is to look at the point they just gave me. I'm literally saying x equals a number. Well, look at your point. Which one of those is x? It's 5. So x equals 5. That's literally the answer. However, if that was a little bit too much of a jump, let's use this graph over here. 5, negative 3 is the point they gave me. 5, 1, 2, 3, here's 5, negative 3. If I have a vertical line going through this point, we know it's vertical because I said undefined. That just further justifies that it's going to go through 5 here, and it's still going to be x equals 5. Okay, again, once you really get Hoy and Vux down, these problems get really, really fast. So let's keep going. Write an equation in slope-intercept form of a line having a slope of 0. Again, huge clue there. That makes me think of Hoy. And the y in Hoy tells me the equation is y equals just a number. Well, again, look at your point. What's the y? It's 4. You're done. Bam. Okay? If that's hard, that's kind of a little bit too much of a quick jump there, go graph that point. Negative 3, 4 is right there. If I was to draw a horizontal line through that, again, I know it's horizontal because of the slope they gave me. Obviously, it's going to go through 4 right here. Y equals 4 is the y-intercept. Slope of 0 makes the x disappear. Okay? But again, as soon as you write y equals, you know that you really are just using the y value. Y is 4. Alrighty? A couple more. Number 6, write an equation in slope-intercept form that represents a line with a slope of 2 and an intercept, an x-intercept of 5. X-intercept, that's important, okay? It's not the y-intercept, so I can't do y equals mx plus b just yet. But because they told me it's the x-intercept, I actually know that my point there is 5, 0. We know the x-intercept is always graphed on the x-axis, so that coordinate would be 5, 0. So now, do I have what I need? Yes, I have a slope and I have a point. It's not my y-intercept, so I have to use point-slope form. So y minus y1 equals m x minus x1. So y minus, well, what does y1 happen to be? Happens to be 0, which is kind of nice. And then m, whoops, I know what m is. Sorry, got carried away. M is 2, and then x minus x1, which is 5. So I just work it out. Y minus 0, woohoo, that's just y. 2 times x is 2x. 2 times negative 5 is negative 10. There is my equation. So my y-intercept now is negative 10. I just want to point out, too, you are now able to graph this, right? You could have before, but you're now able to graph it really easily. Slope is 2, y-intercept's negative 10. Here's negative 10. Slope is 2. You'd go up and over just like this. You'd graph it. You'd be done. The x-intercept would hopefully be 5, like it was supposed to be from the problem. But everything's connected. It all kind of builds on each other. All right, number 7, a repair person charges $25 per hour plus an initial service call charge. The bill for 3 hours was $105. So it says, in the problem, what is the slope? When we think about slope cat, right, what does slope cat say? Ooh, that's a really bad cat, but you get my point. Slope cat says per, right, and I see per right here. 25 is our slope. So what information would be a point in the equation? That means, like, what would be a value, a coordinate pair? Well, they told us that for 3 hours, the bill was $105, okay? It says, what does this point represent? I'm going to say a random point, because it's not the y-intercept, right? It's just a random point on the line that then we can use to create an equation, right? Write an equation in slope-intercept form that represents a situation where h is the hours, blah, blah, blah. Again, like I was saying, we don't have the y-intercept. We don't know 0 and then a number. We were not given that. So we have to use point slope form. So y minus, what's y1? Well, it's from the point. 105 equals my slope, which is 25, x minus 3, the x that was given to me. So I work this out. Add 105. So y equals 25x, what is that, plus 30? Very good. There's my equation. Woohoo. So now it says, what was the initial service call charge? So what did they have to always pay initially? Well, it was that $30 charge. Okay, I got the 30 from right there. So now it says, what will the bill be for 7 hours? Now I have an equation I can use to find any number that I want. So they're giving me 7 hours. That means I just plug a 7 into that equation that I just got. Okay, so y equals, let's see, what is that, 175? Right, yeah, plus 30, so it would be $205. Alrighty, I think this might be the last one, all right? Alrighty, so last one. Graph a line passing through the point negative 10, 1 with the same slope as the line graphed below on the grid below. Sorry about that. So, graph a line passing through this point. Well, again, have they given me a random point or have they given me the y-intercept? Random point, right? Negative 10, 1. That's a random point here, okay? With the same slope as this guy. So, what is the slope? I have to go find it, right? I think I see a perfect point here. I think I see a perfect point here. So that's a rise of 1, 2, 3, and a run of 1, 2, 3, 4, 5. 5, yeah. Okay, so 3/5. So let's use our equation. Y minus, the y they gave us was 1, equals 3/5. X minus a negative 10 makes it plus. 3/5 x plus. Again, to multiply these kind of things quickly, you just do top times top. So 3 times 10 is 30, then divided by the bottom. 30 divided by 5 is 6. Add 1 to both sides, so y equals 3/5 x plus 7. Now, go back and read my instructions. It says graph a line. So I actually didn't even care for the equation, but obviously that was the connection to the lesson. So now let's go graph it. It says y-intercept of 7, slope of 3/5. So up 3 over 5, or maybe down 3 and to the left 5. Ooh, why did that not work? Oh, because that's 9. I graphed the first point wrong. There's 10 right here. Alrighty, so there's our line. And you can tell that we did it correctly because these two lines are parallel because they have the exact same slope. Alrighty, I thought I had, there we go. So let's go back to the pine tree that we were working on earlier. Lines 8, 9, 10, and 11 were not touching the y-axis. So we did not have their y-intercept. So we had done their slopes all the way down, but we did not have a b. So in this given column, you're not going to say m and b. Instead, you're just going to write the point. So again, when I say given, it's like what was given to you, what was provided for you to use. Well, for line 8, I've got my slope of 1/2, because I can just count that out. But instead of me writing a y-intercept, I have to just think of a point, right? Well, here's a point. I know it goes through -1, -1. That's what I'm going to write as the other part of my given, okay? Now, some of y'all are thinking, well, what about this other point? -3, -2. I could have also chosen that one. It does not matter either way. But with the formula set up the way it is, you really only need 1 point, okay? Same with 9. Well, my slope is 1/2. Oops, this one was negative, sorry. 1/2. Oh, no. I'm confused. This one's negative. There had to be somewhere. -1/2 for line 9. But again, I need a point. So again, I could choose that 1, -1, or let's just go with this one this time. It doesn't matter. 3, -2. I'm going to write that down. Okay, so you always have to have either the slope and the y-intercept or slope and a point, whichever one you actually have. So line 10, my slope is 1/3. Oops, I almost wrote b. I don't have b. I don't know what b is. So I'm going to use this point right here. -1, -3. 2. Is that a 2? 1, 2. Sorry, 2. It's hard when you're up at the board this close to it. Honestly, it'd be easier if I stepped back. Okay, line 11, my slope is -2/3. And the point that I'm going to use, I'm going to go with this one down here, which is 4, -4. And again, it doesn't matter which point you use on the line. It could be the right endpoint or left endpoint, doesn't matter. So now, all we have to do is use the point slope formula to find y equals mx plus b so that we can graph it into our Desmos. So, y minus y1, so in this case I've got -1 equals, my slope is 1/2, x minus x1, which is -1 again. Now I work this out. Subtract 1 from both sides. So y equals 1/2 x minus 1/2. There's my equation. I have found my slope-intercept form. Okay. Now I can go put that into Desmos and actually get my line to appear. I do need the domain again, though. So for line 8, it'd be from -3 to -1. Okay, and do this process again. Y minus y1, so in this case it's a -2, equals my slope of -1/2, x minus x1, which is +3. So now I distribute. I'm going to say 3/2. Subtract 2 from both sides, so y equals -1/2 x plus, let's see, that'd be 1.5, so that'd be a -1/2, or yeah, -1/2. That works. All right, so there's my next equation for line 9, and again, my domain would be from 1 to 3. Okay, so your homework is to finish out these 4 lines and to go ahead and graph them in Desmos. So you should have the paper filled out and then also graph them into Desmos. And then the sub also has like a paper homework that you'll just practice using point slope form a few times so that you really have that solidified. So hopefully tomorrow, when I'm back, and hopefully back for a long time, I should be able to check your Christmas trees and check these papers to make sure that you have done everything you were supposed to over the past couple days while I was out. I appreciate y'all working hard and doing what you're supposed to be doing while I am out, and you make my job a lot easier when y'all are such hard workers. So looking forward to see y'all on Wednesday.